So today's topic is going to be multiplexing. Let's see what is multiplexing. The example, there may be n number of different systems that need to communicate to different systems. So those channels will be combined to a single link and then it will be transmitted. So combination of multiple signals and that flow across a single data link is known as multiplexing. See here, that allows a simultaneous transmission of multiple signals over a single data link. In a single path, it will allow multiple signals. So that we'll say it as multiplexing. And the device which we use for multiplexing is called as multiplexer, where it combines n input lines and generate the output line. So this is the step of multiplexing, but at the receiving end we need something that should give the correct communication to the source and the destination. So we use the demultiplexer. Demultiplexer is a device that is used to separate signals into a component signals. So one input and several outputs. This is how the overall multiplexing and demultiplexing works. So here we have n number of input lines and then it is all combined together in a single link, where we can transmit n channels, and at the multiplexing end we are the links are automatically separated. So this is the concept of multiplexing. Advantages of multiplexing is we can send multiple signals in a single link. So that is one advantage, and the other one is it uses the bandwidth very efficiently. So here we can very clearly understand if there is multiplexing and there is no multiplexing. If there is no multiplexing, it is going to be of system to system communication. But if there is a multiplexer and a demultiplexer is enough to communicate between n number of channels, where there may be n number of communications in that, but it will be in a single path. Types of multiplexing: we have three different types of multiplexing. One is going to be frequency division multiplexing, and the other one is wavelength division multiplexing, and the third one is time division multiplexing. In the time division multiplexing, we have two different types. One is going to be synchronous time division multiplexing, and the other one is asynchronous time division multiplexing. So here frequency division multiplexing and wavelength division multiplexing are going to be analog, and the time division multiplexing is digital. First type is going to be frequency division multiplexing. It is a analog technique. So analog technique is conveying information through a continuous signal. So this is how our analog signal will look like. Whereas the digital signal will be in the form of binary, that is zeros and ones. And here if it is a frequency division multiplexing, here different frequencies are combined together and then form a single frequency, and it is demultiplexed to transmit the data. So different frequencies are combined together and it is transmitted through a single link is called frequency division multiplexing. So here in a frequency division multiplexing, the bandwidth of the link is the transmission medium which is used to transfer the data will be always greater than the combined bandwidths of various channels. Here we represent various channels as various systems. Then each signal is having different frequency, or obviously each signal will have a different frequency. For example of frequency is that is going to be of FM. So in FMs we have different frequencies will have different stations. So that we represent as frequency. Obviously we know that each signal will have different frequencies. Then here each channels are separated by a guard bands. See here. Here we are. These are different frequencies. So these different frequencies are separated through a guard band. Applications of FDM. So first is going to be, it is used in both FM and AM radio broadcasting, which I said earlier. Then in AM it has a 530 to 1700 kilohertz. In FM it has of about 88 to 108 megahertz. This is the frequencies, and it is also used in television broadcasting, and the first generation cellular telephone uses FDM. These are the applications of frequency division multiplexing. So this is how the FDM works. So this is different frequencies. All those different frequencies are combined in a single link, and the output is this. In the demultiplexing case, the single frequency will be again divided into multiple frequencies, and then it will reach the destination. Next is going to be wave division multiplexing. So wave division multiplexing is also a analog multiplexing technique. It will also work same as the FDM, but one of the major difference is that it uses optical or light signals, fiber optics, which we will see the transmission medium. So here it uses light or optical signals that are transmitted through a optical fiber. So various light waves from the source are combined together into a composite signal, and then it passes through a single link, and reaches the receiver. At the receiver side, it is broken down into different lights using demultiplexer. So this combination and splitting of light waves is done by prism. So this is the different opticals or lights are sent into the multiplexer, and then through the fiber optic cable only the single link is passed where the signals are combined, and then at the multiplexing phase it just splits away. Next is going to be time division multiplexing. So it is a digital multiplexing technique. So digital multiplexing technique is going to be of zeros and ones. Here it is not, the link is not divided based on, the channel is not divided based on the frequency, but it is based on the time. So total available time in the channel is divided into several users. So each user is allotted a particular time interval, that we'll say it as time slot or slice. So here the rate capacity of the transmission medium will be greater than the data required by the sending or receiving devices. So this is how the TDM works. Here see, these are all different time slots. So in those time slots, each allocated user times will be given. In this we have two types of TDM. One is going to be synchronous time division multiplexing, and the other one is asynchronous time division multiplexing. In synchronous time division multiplexing, so each device will give a same time slot to transmit the data over a link. So there will not be any different time slots, or the time gap will not be longer for something. Everything will be given a same time slot to transfer the data. Where the device has any data to transmit, so it is not based on whether the device is having time slot or not, it does not matter, but each device has the same time slot to transmit the data. So if a device does not have any data to send, then the time slot remains empty. Then these time slots are organized into frames, and each frames consist of one or more time slots. If there is n sending devices, then automatically there will be n slots in the frame. See, this is going to be your frame. So each frame is given a, each device is given a time slot. This is your first mission, second mission, third, fourth, and fifth. So they are varied in the colors. Each, if this does not have any data to send, even though the time slot will be given for this to send the data. So this is called synchronous time division multiplexing. Let's see how the synchronous time division multiplexing works. We have four different systems, and for the four different systems we will be given four time slots in the frame. So only first system is sending the signal data, so first is given, and the other three time slots are empty. In the second frames, two systems are sending the data, so two systems are filled and the other two is left empty. So this is how the time division multiplexing works in the multiplexer phase. So in the demultiplexing phase, using the demultiplexer, each data is transmitted to the original link and then reaches the destination. So here one of the disadvantages is that if some frames does not have any data to transfer, that is not utilized. So that is one of the disadvantages here. Then it is asynchronous TDM. Asynchronous means it is also known as statistical time division multiplexing. Here there is no time slots are not fixed. The time slots are not fixed in this. So the slots are flexible. If a system does not contains any data, then the time slot will not be given there. So total speed of input lines is greater than the capacity of the path. So here the slots are not predefined as I said earlier. They are allocated to any device that has data to send. This is how the asynchronous time division multiplexing works. We have 5 systems, but only 3 systems are going to transfer the data. So those 3 systems will only be given time slots in the frames. So this is the overall process of your multiplexing. So we have 3 different types of multiplexing and each works in a different ways. Thank you.